So here we go. Supposed to calculate all of these things for the following polygons, and remember, what do those letters mean? If it ever asks you for sum of interior angles, you got to use this formula. If it asks you for an interior angle, exterior angle, central, and D, right? So S, I, E, C, D, okay? So that's where you're going to go. You need to know the number of sides. This is a nice little bonus that I'm going to offer to you on the test. I will use the name of the polygon, like let's say dodecagon or decagon or whatever. If you don't know what that is, I'm going to also have a diagram of it. So you need to count the sides if you don't know what that word tells you, okay? Decagon, for example, is 10 sides, but I will have an actual decagon on there. So then you count. If you don't know the name, if you don't know how many sides that name is representing, count those sides. So that's what I'm going to do here. I'm check mark for my starting count, right? 1, 2, 3, 4, 5, 6. In this case, n is equal to 6. That is actually called a hexagon. That's the most popular polygon probably out there. Pentagon, hexagon are probably the most popular, right? Seen in nature, seen in a lot of applications, right? So if you don't know where we are, 203, find 203 and then flip over until you find this one. I'm going to find the sum first. The sum, if you look at the formula, I'm not going to write it out because I will run out of space. It's a little bit different than what I gave you. I like to have the n minus 2 front. So it's 6 minus 2. I want you to show me that times 180, right? 4 times 180, really. So that's 720. Page 203, just keep flipping until you find this. So that would be the sum. Let's pay attention to this. Like, I want you to know what this means, because if you just find it, it's kind of useless. Let me zoom into that in case you're squinting. Right? This is the sum of all interior angles. It works every time. So if you want to know what all of these would add up to, that's what it adds up to. Okay, that's what we just found there. The interior angle, folks, is essentially taking the 720, dividing it by the number of sides, right? So that would be 720. I know that the top is 720, right? I already calculated that up there, but you have to divide it by the number of sides. So the interior angle is 120. This particular polygon has each interior angle equaling 120 degrees. What kind of a polygon is this if they're all 120? If all angles are the same and all sides are the same, what do we call it? Walter, were you saying something? It starts with an R. Regular. Regular means all sides are the same, all angles are the same, all right? That's all it means. So a square is your perfect example of a regular polygon. An equilateral triangle is another perfect example, right? So there we go. Let's find the exterior angle. Exterior angle, look at your formula. It's like, I have no idea how to do this, Mr. Dirksen. Well, today's your lucky day. You find the exterior angle on your formula sheet and you know you need to take 360 degrees and divide it by n. What in the world is n? Number of sides, okay? So 360 divided by 6. If this had been a nonagon, this would be divided by 9. Decagon divided by 10. 45-sided polygon, you would divide it by 45, right? It's not that crazy, right? So there's your 60 degrees. The central angle is the same formula. So it's going to give you the same answer. Okay? So we found the sum, the interior, the exterior, the central, and we need to find out the number of diagonals. So I'm going to do that here. The number of diagonals is taking the number of sides multiplying it by the number of sides minus 3, then dividing the whole thing by 6. No, it's not 6. It's always 2, by the way. Where did I get that formula from? Right here. The number of diagonals is using that formula. Yeah. 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 You actually can bring the blue and the yellow every time. Support Ukraine at the same time. Right? 2 and 1. 6 and 3 over 2. That's 9. I'm not going to ask you to draw them ever. I'm just going to ask you to calculate. You can draw them, would not recommend it, because even if you're off by 1, I have to take marks off. Right? Let's just quickly label what we found. Ice can be, right, winter pack, ice, you shouldn't forget that. We know how to label them on this diagram. So if I ask you to label one of the interior angles, I want you to make a little arc like that and say that, right, that is an interior angle right there. If I ask you to label a central angle, find a center and go to make a slice, an arc like that, and call it C. Okay. Exterior angle, where's the exterior? This is the hardest one. This is what I get a lot of times, which is close, but it's wrong. Right there, Mr. Dirksen. That's your E there. Nope, it's not right. And this is what I tell my students. Find any side. Close your eyes, land on it. Travel along it. Either way. If you want to travel this way, just keep extending it when you exit. And so that's where the exterior angle is located. Okay. So we found all of those on there. Brady, would you mind closing the door properly? Is that howling? We've got everything out here in the cabin. We've got coyotes chasing rabbits. We've got howling doors, winds, everything. We got wasps. We got it all here. But don't worry, I'll take care of that. Next, we do this one here real quick. I'm going to be quicker here. So I don't know the name of this shape. So I'm going to count 1, 2, 3, 4, 5, 6, 7, 8, 9. I have 9 sides here. Let the story repeat, right? So sum, I'm going to use my formula, which is right here. It says take n, subtract 2 from it, multiply it by 180. So that's 7 times 180. Is that 900? No, it's not 900. Sorry. I'm guessing here. You should not be guessing. 1260. I was thinking of a heptagon. 1260. So what did I just find? That all of these interior angles, if I add them all up, it would add up to 1260. Okay? It works for a triangle, works for a square, works for anything. Then the interior angle, just one of them, can we just say that it's going to be 1260 divided by 9, right? You can use the formula from scratch, but if you already know what they all add up to, just divide that by 9. And I'm going to do that on my calculator here, and that's 100 and... No. Let me check. Did I make a mistake? 1, 2, 3, 4, 5, 6, 7, 8, 9. I have to go 9 minus 2 times 180, which is 1260. So that's 140 degrees. Yes, that's right, sorry. 140. I know octagon is 135, so there we go. 140 makes sense. Sum of all angles, interior angle. Let's find out the exterior angle, which is 360 divided by 9. It's always 360 divided by 9, which is 9 times 4, right? So it's 40 degrees. Do you remember what I said, that interior and exterior always add up to 180? Yeah, 180, and it always will be the case. So if you know that, just subtract the interior from 180 to get the exterior. You can use that as well. Central is 360 divided by 9, which is the same. So we have sum, interior, exterior, central, number of diagonals. I'm going to do that from scratch. Sides, n, right, times n minus 3 divided by 2, which is 9 times 6 divided by 2. And that's 27. Diagonals. Good luck drawing them, right? It's actually beautiful if you use different colors for every single one. It looks very nice, but art, I'm not really artistic, so I'm just going to leave it at that. Okay, so this is the kind of stuff that I'm going to ask you today. Does anybody remember, if I took all of the exterior angles and I added them up, what do they always add up to? The exterior angles. 360. Always. It could be a 100-sided polygon. Good luck drawing that one, right? If you were to add up all the exterior, the ones that are on the outside, let's label one here. Find this side, for example. You get to the corner, travel straight out. That's one exterior angle right there. And the interior would be right next to it. That's the best way to show that they would always be supplementary. And a central angle, find a center. If you know how to label them, you'll probably score 3 marks just there if you know where they are, right? I usually give 1 mark for each, but make sure the exterior angle is labeled properly, not just going out like that, right? You have to continue one of the sides almost, right? And then make your exterior angle. So we're gonna write our AC. You're gonna feel like I'm gonna push you a little bit today, but I want to get everything done so that tomorrow I can focus a little bit more on reviewing and getting you ready for that test, right? For the test, the only thing that is from a previous unit, there's one question, which is buying used versus new. Review that a little bit. There's only one question worth 2 marks of that unit of vehicle finance. Everything else is this unit right here. We're going to review the cosine law a little later. We're going to do these two here a little later, so not now. You don't need that for the AC today. And just be honest, right? No need to hide the truth, right? You are where you are. We're going to make you better at it, okay? Label one interior angle. So you go anywhere at a corner, make one of these arcs, and then put an eye there, right? If you didn't put the arc, it's fine, as long as it's right there, somewhere at one of these corners, right? Exterior angle, right? Grab any side, just extend it. That would be one of the exterior angles. And a central angle, you go to the center, and you just make one of these, right? That's your central. Understand that this has 1, 2, 3, 4, 5, 6, 7, 8, 9 sides. I did one of these just now anyways, right? 9 sides. So technically this one has 9 central angles, 9 interior angles, 9 exterior angles, right? There's one at every intersection, right? Calculate the sum of interior angles. Just show me the formula. However you have it, it's 180 times 9 minus 2 or vice versa. It doesn't matter at all. Is that 1260? Yeah, okay. I have a good memory. Calculate the measure of one interior angle. That one is 9 minus 2 times 180 divided by the number of sides, right? So that would be 1260 at the top divided by 9. which is 140. Sorry, you get 1 mark for each correct answer there. Calculate the measure of one exterior angle. You go to your formula sheet, you find exterior angle. It says 360 divided by n, which I already determined is 9, and that is 40 degrees. Or you go 180 minus 140. Calculate the measure of a central angle. It's also 360 degrees divided by n, which is the same. You get 1 mark for that. Calculate the number of diagonals. I didn't know that this was on the AC. That I just did the 9. I shouldn't have done it, but hey, you get the freebie there. N times n minus 3 divided by 2. That one is divided by 2 always. You will never get a decimal there. If you get a decimal, you did something wrong. Go back. That's 9 times 6 over 2, which is 27, right? You get 27. Make sure you put your brackets in if you type it in or something like that, or else I would do it in steps just to be sure. This is a question. What is the sum of all exterior angles in any polygon? And the answer is 360. It's always 360, so you get 1 for that. So 1, 2, 3, 4, 5, 6, and 3 is 9. This page is out of 9. Okay, and then you get to do this all over again, pretty much. I just want you to know how to do it, because if you know how to use the formulas, you have chances to score marks. If you know your properties of the quadrilaterals, you know how to sketch them. If you know how to classify triangles and sketch them perhaps, and you know all those stuff, like you're in good shape, right? If a polygon has a central angle of 20, oh, I don't know if you knew this one. This one is tricky. If the polygon has a central angle of 20, how many sides does it have? Calculate this. Today I'm going to give you the marks if you get the right answer. So basically what you want to use this formula. The central angle is calculated going 360 divided by n. They want to know how many sides it has. They give you that 20 will go into that where the C stands, right? So it's 360 over n. What does this look like? Remember that? I don't know if I showed you the trick putting the 1 under. It should remind you of cross multiplying and dividing, right? So it's 360 times 1 divided by 20. And that will be 18. Let's make this a bonus. So if you got this, you get 1 bonus mark. If you got that right, but if you showed the work, that is, right? You get a bonus mark. Yeah. You just put 18. Sure, I'll give you the bonus mark. Yeah. Yeah, today I'll give you the bonus. I'll show you how to do it later, like this. Yeah. We'll give you the bonus mark. Next, consider the hexagon. I told you on the test, I'll give you a diagram. So n is equal to 6. Sum of interior angles would be 6 minus 2 times 180. That is 720. I did that as well. Thank you, Mr. Dirksen. You're welcome. Central angle is 360 divided by 6, which is 60. The interior angle is 6 minus 2 times 180 divided by 6. So that is 4 times 180 divided by 6, which is 720 divided by 6, which is 120. So many steps, right, just to get that. Number of diagonals, that one is 6 times 6 minus 3 divided by 2. That is 6 times 3 divided by 2. That is 9. 9 diagonals can be drawn on a hexagon. Measure of one exterior angle. The exterior angle calls for 360 degrees divided by the number of sides, which is 6. It's 60 degrees. So I just mixed it up a little bit, so you have to go and find the right formulas. 1 mark for each. Okay. Now the tougher cookie here. Consider the following 5-sided polygon. Determine the sum of interior angles. The sum of interior angles, right, is if it's a 5-sided, that'd be 5 minus 2 times 180. That is 3 times 180, which is 540. All angles on inside this have to add up to 540. So calculating x, therefore, is going to be 540 minus, I'm going to subtract all the angles that I know. Right? These 4 are known to me. I just read them off. And so that adds up to 60. Simple as that. So this page is actually out of 7 because I'm getting rid of question 2. So it's 7. You could score 8 potentially if you got question 2 right on this page. So 7 and 7 is 14. No, 9 and 7, 16. Sorry, it's out of 16. Where you could potentially score 17 out of 16 if you got question 2 right. Okay. All right, name and last name. Pass it forward. And I want you to go back to your booklets to where we just ended up. We just ended up right here. I want to continue with that. Okay. So pay close attention to this. Determine the perimeter of this polygon. The perimeter. What's the perimeter again? The distance around it on the outside, right? So if we find x, if we find this length, we're going to multiply it by 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. N is equal to 10. Okay. But the first task is to find x in the first place, right? I need to find that. So I'm going to zoom into just that side for now. So let's find x. If this is 13, this is also 13. That is a fact, right? It's an isosceles triangle. If I could find this side right here, this angle right here, what kind of a triangle would I have? S, A, S. And then I can use cosine law. Remember that? It's been a while. So what angle is this? What do we call this in the polygon world? Central. Okay, you're with me. You're with me. So central angle is 360 divided by, what is it? Divided by 10. So that angle is 36 degrees, right? Let's write that in there. You're with me. That's good. So that is an SAS. Some of you are saying SOS, right? Get me out of here. But it's an SAS, right? So I'm going to do SAS. Let's solve for side X. So I'm going to go, whatever this is called, it could be called A, B, C, X, M, whatever. X squared, right, is equal to these two sides added and squared. So it looks like Pythagorean theorem at first. Then I have to go minus 2 times the first side times the second side times cosine of 36. This angle, this central angle, could be is going to be different. It depends on the number of sides. Okay, so x is going to be, let's type that in. I don't know if you remember how to do that, but I go 13 squared plus 13 squared minus 2 times 13 times 13 times cosine of 36. I get 64.5522559. I'm going to take the square root of that. You're writing this down, right? Yes, sir. I'm just going to cut it here and just say this is approximately 8.03 inches. And I say approximately. If they asked you to find x, then that would be the answer. We round it, of course. And here's the last piece. Perimeter is going to be number of sides, right, multiplied by x. In this case, the number of sides is 10, x is 8.03, and that would be 80.3 inches. The one next there is for you to do. Okay? Before I move on, I want you to try this right now with the one that's right next door before I move on to my other examples. Okay? I'm going to leave that up there. Yeah, it's technically 80 if you use all decimals. And the perimeter would be 11 times 151.8 feet for the perimeter. Go ahead. But wait, there's more. Okay, I'm going to do a couple more examples. So. This calculator will square it minus 24.5 and 24.5 times cosine of 32.72. Have that all answered backward in the root. That number goes in the root. And then you press this and equals, and then you will get your final answer. Good? Okay. Couple more examples, guys. So write this down, okay? Z is this, P is that. If you need some alone time practicing this, right, you know the answer, okay? I may or may not have an AC tomorrow where that is being asked of you. Intent. Wink, wink, right? A regular polygon has an exterior angle of 40 degrees. Calculate the number of sides. When it says the exterior angle, I want you to think of the formula. Like they're asking you for the number of sides, right? So the formula for exterior angle is 360 degrees divided by n, okay? Where E is given to you. So I want you to, if you want full marks, okay? If you want full marks, you need to set it up like this. Put a little 1 under because it doesn't affect it. That way you know you have to cross multiply and divide. Right? So it's 360 times 1, which is irrelevant, but we still do it, right? And so in this case, it has 9 sides. What do we call a 9-sided polygon? A nonagon. Okay? This is the name of that particular polygon.
Excuse me, interruption. Could Coda please come to the guidance office?
Sure. Let's keep going. This is the easier case. So I call these, write this down next to it. This is backwards, where you're finding the number of sides. You're not finding the central angle or exterior, you're actually going backwards. So you need to start with the formula, plug in on the left side what you know, and then try to figure out what n is equal to without just guessing. If you just guess and check, you're not going to get the marks there. Okay. So follow me here, next page. That one is very easy. We're not going to do that one. This one is very hard. So this is going to be a bonus if that ever shows up. So I'm going to put a star next to it. Yeah, not today. Not today, because I'm running out of time. What does it mean for a polygon to be regular? All sides are congruent. All angles are congruent. If one of them fails, then it's not a regular polygon. Okay. Those are two things that you must know about it. Nine, a hexagon has the following. Focus on that. A hexagon, right away you should know how many sides does this thing have? How many sides? How many sides? Right? A hexagon has interior angles of 125 and two angles that measure 24. Determine the measure of the sixth angle. That's like, this is like our unknown angle. You need the sum of interior angles. Sum for a hexagon is 6 minus 2 times 180, which is, anybody remember? You did it a bunch of times today. You know that the word hexagon tells you that all of the interior angles add up to 720. Therefore, that sixth angle we're interested in, we're going to take that 720. If this had been a heptagon, you figure out how many, right? The sum for a heptagon, and then you start subtracting the ones you know. So 1, 2, 3, 4, and there's two angles that measure 124, right? Two angles that measure 124. So 1, 2, 3, 4, 5 angles we know. So we're just subtracting that from 720. And I actually need to figure this out myself, or do I have that on my key? I don't. Okay, so somebody can beat me to it. 111. Is this a regular polygon? How do we know? It's obvious, like, but all angles are different, right? I hope that will be obvious when you write your test. If I ever ask you something like that, irregular, right? Since all angles are not congruent, you cut it like that. Well, you can just tell me all angles are different, the angles aren't all the same, like use your own words. We're all good here. I encourage you to use your own words if you need to. But we don't even care about the sides, right? We know that the angles are all different, therefore it can't be, okay? And I just had an idea here. I know I'm pushing you right to the end, but that way tomorrow I can spend a little bit more time reviewing these. Let's go back up here to the bonus, quote unquote. I'm going to leave that there, But let's do this one here. This one is so easy, I want you to just cross that off. We have done it already, the interior angle of a hexagon. But let's see here. Can you write this down? The sum of interior angles of a polygon is 1800 degrees. Calculate the number of sides. This is also a backwards example. So if you want to write down backwards, we are going backwards anyway. See how I did that? What I did there, right? We're going back. But it's the sum is n minus 2 times 180, correct? We're talking about the sum of interior angles is 1800. Calculate the number of sides. So we need to start with this formula. Let's substitute the 1800 into here. And that is equal to n minus 2 times 180. That would be step 1. Allow me to do this here, arrow, right? Showing what I did, right? If you have a different color, do this now. Teachers will do this differently. I get rid of the 180 first. So I'm going to divide both sides by 180. That way I can cancel that out on this side. And I'm going to go arrow like this. That leaves me with, what's 1800 divided by 180? Mental math. 10. It's all good. It's all good. It happens to me all the time. And I'm a math teacher. It shouldn't be, right? So then you're left with that. And what, I don't know how you were taught in the previous years, but I'm going to go plus 2 here and plus 2 on the other side. I'm going to add 2 to both sides. So then it's n, right? Because these two cancel out. 10 plus 2, you can do this one. 12. 17. 21. Dodecagon. So the bonus, I will do that. I can't do it today. It will take too long. I will do this one tomorrow. Remind me. Hold on. Yeah, no, we'll do review tomorrow.